Hi, my name is Justin Klein, and today I will be presenting to you my final project, which is change detection of land cover in New Hanover County. So my research questions I will be addressing was how much has the land cover changed in New Hanover County from the years 2000 to 2019, and in what areas of New Hanover County are seeing the most significant change in land cover. And so a little overview, the East Coast of North Carolina has seen an increase in development since the start of the 21st century. I got my undergraduate in environmental science, and I currently work in the construction industry as an inspector. And so I see the growth of construction across New Hanover County on a daily basis, and I thought this would be an interesting investigation. And it'll also, in the future, maybe help with developmental planning in the future. So for my data, I chose to use Landsat 7 and Landsat 8 imagery. I chose these because the spatial resolution was the same across the years 2000 to 2019, and I was also able to find imagery within the same season. That way we would not confuse the forested areas. I also extracted a New Hanover boundary from a USA county boundary dataset from ArcGIS, and I use that as a clipping boundary for my satellite imagery. So for my methodology to investigate the land cover change in New Hanover County, I chose to use the supervised classification method, and here I separated the land cover into 6 different classes: water, developed, forested, herbaceous, wetlands, and barren. And I wanted to put an emphasis on the expansion of developed land and the decrease of forested land. And some of the spatial operations I used was clip raster, training samples, supervised classification, and change detection using calculated geometry and the attribute tables of the classified images. So here you can see my flowchart of the methodology used. Essentially did the same thing for both the 2000 and 2019 data. I clipped them to the county boundary, performed training samples, then I performed a supervised classification, and then calculated the geometry and the attribute table, and then compared the results. So here are my supervised classifications, the 2000 being on the left and the 2019 being on the right. And visually we can see there has been a significant change in both developed and forested area. And if we look closely, generally the change is occurring in the central part of the county, but there are little changes here and there across the whole county. So here's the analysis of my data. I gathered these percentages from the attribute table and calculating their geometries. Over in the percent change column, if we see a green cell, that would mean a net increase in area. And if it's a red cell, that means we saw a net decrease in area. So for our urban and developed area, we saw a 7.5% increase, which was expected. And in our forested area, we saw a 22.5% decrease, which is a little alarming, but we can attribute this change to the urban and developed areas, the barren areas, and also the wetlands. And for the wetlands, it's an interesting topic because we have these small inland islands that were once forested, but over time, the slightest increase in sea level change has actually converted these once forested islands into wetlands. So as expected, there was an increase in urban area and a decrease in forested area. We already discussed where that loss of forested area could be attributed to. There was a slight confusion of classification in the sandy beach areas, which matched the reflectance values of some urban areas. So for a more accurate investigation, I speculate we use imagery with a higher spatial resolution. That way our pixel sizes are a little smaller.